Hello everyone, today is the 20th day of Leetcode 75 challenge. Let's begin with the 20th question. Question 2215. Find the difference of two arrays. The level of the problem is easy. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Let's understand the problem in the easiest way possible. So you have been given two arrays which are nums1 and nums2 and which contains integers, fine. And these arrays may have some numbers in common and some that are different, fine. Basically, two arrays are there and X is present in this array also and it could be present in this another array also, fine. And your goal is to compare these two arrays and figure out which numbers are unique in to each one. Basically, the numbers which exist here are unique to the numbers which exist here. Basically, the numbers here are 1, 2, 3, which and it is not present here. Here we have 4, 5, 6, fine. And we have to return both sets of unique numbers as list containing two sublists. The first sublist will have number only found in nums1. Sublist means kind of a 2D list, fine, a 2D array. The second sublist will have numbers only found in nums2. Okay, the numbers found in nums1 will be stored in this sublist, and numbers found in nums2 will be stored in second sublist. Where answer of zero, basically let's name this as answer, this and result as okay. Answer of zero, which means this sublist, list of all distinct integers in nums1, fine, which are not present in nums2, and where nums1, which is basically this one, is a list of all distinct integers in nums2 which are not present in nums1, fine. So basically this contains distinct elements which are not present in this sublist, and this sublist consists of those numbers which are not present in this sublist, fine. Basically, nums1 values are not equals to nums2 value, fine. That's all. That's what question is asking to us, that we just have to create two sublists which contains unique elements, and those unique elements are not present in each other sublist, or basically elements which are present in nums1 are not present in nums2, and elements present in nums2 are not present in nums1, fine. The constraints of the problems are the nums length could be going from 1 to 1000, and similarly nums2 length, and the values could be from -1000 to +1000, fine. I hope you understood the explanation of the problem. Now let's move to the next slide. Let's understand the input output of the problem, fine. So here we can see nums1 is 1, 2, 3, and nums2 is 2, 4, and 6, fine. Let it be nums1 and let it be nums2, fine. Okay, and output is 1 comma 3 comma 4 comma 6, because if you can see 2 is present here also and here also, fine. So we cannot take those, but we can see that 1 is not present here, so it is unique. 3 is also not present here, so it is unique. Therefore, we have 1 and 3 here. And in this case, 4 is not present in this array, and 6 is also not present in this array. Therefore, we have 4 and 6 here. So I hope you understood, like basically we are taking those values from this array which are not present in the second array, and vice versa. Fine. Let's take the second example. 1 comma 2 comma 3 comma 3, then 1 comma 1 comma 2 comma 2, fine. Here you can see output is 3 comma empty. Why? You will be saying that we have 3 here and we don't have 3 here, so we have taken 3, fine. But we have 3 again, right? Now we have to keep in mind, and it is not clearly said in the question, that if you have same elements or same number multiple times, it is considered as one group. Basically, for example, if you, in this case, since you are given 1, 2, 3, 3, fine. This 3 is only one. Basically, you could say that type. There is a name 3 type, so this is only one. So it will be reduced to 1 comma 2 comma 3. I hope you understood, right, what I'm trying to say here. And in this case, 1 comma 1 comma 2 comma 2, having repetitive elements means it's a single elements only, right? So it will boil down to 1 comma 2. Now if you compare both elements arrays, 1 2 are common in both, so output comes out to be from first array 3, and from the third array it remains empty. Fine. So we have to keep that is also in mind that if we have the same characters repeating, same numbers repeating in the array, we have to take it as one only. Fine. I hope you understood the input output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem first. Fine. So imagine two friends, Alex and Ria, each with a bag of marbles. They sit down, open their bags, and start comparing marbles. Great. Now, some of the marbles are the same color and size, but some are completely different. Now, Alex wants to know which marble do I have that Ria doesn't? And Ria wonders which ones do I have that Alex does not? Fine. So they don't care about how many times a marble appears. This is also an important point. Keep this in mind. This point, right? Even if Alex has five blue marbles and Ria has one blue marble, basically, they are treat it as just one kind of marble. Fine. As we saw the example also, if we have multiple threes, we take it as only one three. Similarly, if he has five blues marble, so it will be only one blue marble. And similarly, Ria since had only one, so it will be one. Right? Okay, this is the scenario. And they also trying to say that the marbles, which marbles do I have that Ria does not? So Alex trying to say that how many unique marbles does he have compared to Ria? And Ria also thinks the same. How many unique marbles does he have compared to Alex? Fine. This is our intuition build-up, a storyline for the intuition. Now, what is the how to approach in and what is our goal for it, right? So now understanding the goal in this point is that if you are not comparing quantities of marble, but rather types of marble, keep this in mind. As explained to us in the explanation also and in the intuition scenario also, we are not checking that how many times 3 is appearing. If it's appearing one time, and then after that, if it is appearing more than 1,000 times also, we will be taking it as only 1 3. So it instead of becoming quantities of 3, it will become type. That fine. Type means we have 3 type and its quantity is 5. Understand it in this way. Fine. Great. Now let's move ahead. They Now the task is to find the marbles that are unique to each friend, right? This is our task. Comparing with the example also, we have to find that how many unique numbers that are unique to each other, right? Or nums1 and nums2. Now once that only exists in Alex bags or only in Ria's bags, right? Basically, one only exists in Alex bag or in Ria's bag, but not in both of their bags. Fine, great. Now the importance of distinctions. Now, Alex might say, I have red and green marbles that Ria does not have. Great. Meanwhile, Ria replies, I have yellow and purple ones that Alex doesn't have. They want to know what makes their collection special from each other. Fine. So here basically, he has two unique marbles and she has two unique marbles. So the output will be, in Alex case, it will be green marbles and red marbles. And for the Ria's will be yellow and purple marbles. Fine. I hope you understood this intuition and how we're building it. Now, thought which comes to our mind is that how we will do it in our given scenario of the question. Now, if you understood the intuition, what a person could be doing, right? First and foremost things, Ria and Alex will be like let Alex have red, R means red, two red marbles, green marbles, G, blue marbles, and yellow marbles. Alex, fine, okay, and Ria will have let's take red marble ones and blue marble ones. Then she has orange. Then she has brown. Let me write it brown here, full spelling. And what else she has? She has pink, P color, P. Right? Great. Now what Alex will do? Alex will talk to Ria. Alex will see in Ria's bag. Okay, he sees that I have two red and she has one red. So this boils down to red type, green type, blue type, and yellow type. Fine. Here also red type, blue type, Since he has all the unique elements, let it be brown and pink, there is no type, there is no multiple values here, right? Now he checks, okay, I have red. Ria also says, I also have red. So what they do? They remove red or they keep it aside. This is what they will be doing. Now they check, do you have green? She says, no, I don't have green. Fine. Then he says, do you have blue? She says, yes. So they both remove blue from their bags. Now he says, do you have yellow? She says, no. And neither of their colors are matching. Now he lays out his marbles, which is green and yellow. And she lays out her marbles, which is orange, brown, and pink. Now this comes out to be the answer. Fine. This is what a practical scenario will look like. And similarly, in our code also, we will be doing the same practical thing. If you can observe what we are doing, we are first thing, if we have multiple quantity of same number, for example, if we have 3 multiple times, we are reducing it to one quantity of 3. Fine. The second thing which we are doing, if we have common elements in both, we are throwing them out from the arrays. Great. If you can read it here, how to compare the collection. As I explained, they will lay out the things and they will start removing their set types. And what left for each person is the unique to the collection. Now, if you can recall, there is a data structure which we can use here in Python, right? Which stores only unique elements with it itself. If you can recall, it's fine. If not, let me reveal it to you. It's sets. Fine. A set always stores unique elements with it. Fine. And if Alex throws his marbles into a set, he will only be remaining with one red, I think one blue, then I think yellow, and then green. And since Ria already have unique marbles, I think they were red, brown, orange, and pink. Great. Fine, fine, fine. Now what they have to do? If I subtract both of them, like if I subtract nums1 or Alex bag with Ria's bag, brown will be eliminated. Fine. Sorry, not brown, not blue. Red will be eliminated because it is common in both of their sets, right? If you can see here, finding what's in one set and not the other is saying like, show me what's mine but not yours. So this way thinking, let's clearly identify the unique pattern of each array, giving us exactly what the problem is asking for, which is clearly using the concept of sets, right? So this is the thing. If you have two sets, set 1 and set 2, and if you subtract them, right? So in this set 1, you will have only elements which are present only in set 1. And when you do set 2 minus set 1, you will have only elements which are present in set 2. So this is the data structures which we can use and which will help us to solve this complete problem in the easiest way possible. So this problem boils down to the problem of sets, or the hashing, because hashing sets comes from the concept of hashing itself. Fine. I hope you understood the intuition and how we came to know about that, how we will be using the set here. Now let's move to the next slide. Before going to the approach, let's understand what is set data structure in depth. Okay. So a set is a built-in data structure in Python that stores unordered unique elements. Fine. These two things are important. It is particularly powerful when dealing with problems involving membership checks, duplicates removal, or mathematical set operations like union or intersections. Fine. Basically, if you do set 1 intersecting, set 2, so you will get only elements which are common in both. Fine. And if you do subtraction, so it will give the values which are present only in set 1 and or in set 2. Fine. Now, what are the key properties of sets? There is no duplicate elements. First thing, fine, checked. It is unordered, no indexing or slashing. Checked. It is mutable, can add or remove elements. Fine. Support standard set operations, which are here I will discuss with you. And why it is efficient. This is the important thing, right? Why we are using set in of our DSA problems, because Testing is O of 1 average thanks to hashing. It takes only O of 1 time in average to do any application or operation of set. Eliminates duplicates automatically, efficient, useful in problems involving checking if elements repeat itself, basically duplicate element. Fast lookup whether this element exists in set or not, and comparing data sets. Fine. Now, what are the operations? Fine. Adding into the set, removing from the set, checking membership. Like if you go in add, right? So s dot add adds an element to the set. Fine. Remove s dot discard 2. So removes if present. No error if missing. Basically, if 2 is present in set or not, right? Then remove it. Checking membership if 3 in s. Check if an element exists in set or not. Fine. Union means what? S2 or S1. Okay. Any of the time. Union with S2. Fine. So if we have something values in set 1 and in set 2, and when you make the union of both of them, so it creates one big set of unique elements. Intersection is this common elements only, as I said, and difference, subtraction, items in S1 but are not in S2. Great. This is all about set data structure we should be knowing about for our solving any DSA problems. Okay, now let's move to the next slide. Now, since we got the intuition of the problem, let's look into the approach how we're going to solve it. First and foremost thing, defining variables. Initializing variables for handling the unique elements. So first we will do set one, or we will initialize set one. Fine. For example, if we had elements in this way, right? In our nums one, and what we are doing, converting nums one to a set, keeping the only distinct elements as we discussed earlier. So what we did, we put as nums in a set. So it boils down to 1, comma 2, comma 3, comma 4. Okay. Now we can see that set one consists of only unique elements now. It is a set. Similarly, we do with the set 2. Suppose set 2 also we had some values in repeating type, and when it was entered in set 2 or converted into a set, so it will be boiled down to 1, 2, 3. So this is what we did in these two steps. Fine, converting them to a set. Okay, this is the first thing which we did because we want unique elements so that we can do our next operation. As first thing was, if there are multiple elements, as our intuition build up and also the problem, introductory explanation. If we have threes multiple times, you have to take only 1 3. It will be considered as 1 3 only, right? For that, we used set. So this is done. Now identifying unique elements. Now find the elements that are in nums1 but not in nums2. Now if you remember, we discussed that there is a operation in set which is called difference. Fine, which basically says s1 dot difference s2. It basically says that suppose there are common elements in both s1 and s2. When we do this, s1 will only consist of elements which are only unique to s1. Basically, those elements which are not in s2. If we had 1, 2, 3 and in s1, and we had here 1, 2, 4, let's suppose 1, 2, 4. So now s1 will be only having 3 with it. Fine, and vice versa. And the s1 dot difference can also be written as s1 or set 1 minus set 2. Both works the same way. Great. This is why we did use the difference operation of set. So because of using set, we can tackle down two things here. First, having unique elements in our array. So as the question asked. Second thing, when we do the difference operation, we get only elements which are present in nums1 and then in nums2. Fine. Here also we do the same. If we do set 2 minus set 1, only unique elements of set 2 will be there. If we do set 1 minus set 2, only elements of set 1, unique elements of set 1 will be there. Fine, that's the thing. That's all. We did these two things. Now what to do? Now step 3 is format the result. Now, if you remember, we have to return the array in 2D array format kind of a thing. Fine. Or you can say 2D array itself. So the output should be of this kind. Unique nums1 and unique nums2. Fine, this way. So what we do? We combine both the results into a list in a single output this way. Since result was already a set, you can say array, an array kind of a format, and set2 was also an array kind of a format. So I put it into a list type of a format and I returned it. That's all. List of two lists. That's all. It was in the list format itself. Result one. We converted into a list also here. If you can see, right? If you directly put it into the array directly, it will give you an error. So we have to convert first into a list. This both of them. Then put these two lists into another list, which we did here. So it makes this kind of a format. So this is the approach. The question was very simple, but this question helped us to understand the use of set data structure, which comes up from the concept of hashing. So I hope you understood this complete approach. Right now, let's move to the next slide. How hashing set is helping us. Fine. How set is helping us here. Let's give a point in the nutshell. That sets automatically eliminates duplicates. We know about it. Great. That's why we only compare the unique values. Faster lookups, basically searching elements in sets makes us easier. Like set operation, this are optimized using hashing, which is done in all of one complexity. Fine, on average. Simplifies the logic instead of writing nested loops. Clean set operations finds the difference directly. Improves performance how? Overall time complexity is reduced to O of n rather than O of n square with naive approaches. So if we have used any naive approaches like going through the array twice, thrice, or using multiple loops, so to make the elements unique, then taking out the difference between the both the arrays, right? So that would be having a headache and a lot of codes and less efficient. So this is how the hashing or set is helping us in this problem. These are the four main core problems it solves. Fine. Now let's move to the next slide. The code is exact copy of the approach we discussed. Let's understand it line by line. First, we convert nums1 into a set, done. Nums2 into a set, done, and store it in set1 and set2. Then we take out the difference of both the sets and convert it into a list and store it in result one. Similarly for result two, and we just return them in the format of to-do list. That's all. Now time complexity is O of n plus m. Why n plus m? Why not O of n? Because the length of nums1 and nums2 could vary. It could be of length 6 or it could be of length 3, right? So you cannot just say that it's of length 6. It will be of length 6 plus 3 total time complexity, right? That's why n plus m. And space complexity is O of n plus m. Same scenario. Why? But since we are using set here and result to store the answer, that's why the time complexity comes out to be O of n plus m. That's all. I hope you understood the problem. Now let's move to the next slide. Let's see the dry run for the problem. If we take 1, 2, 3, and this is second array 2, 4, and 6. Fine. Converting into a set will result in only in 1, 2, 3 itself because all elements are unique here, set 1. And converting this to a set will also give me 2, 4, 6 because both the elements are, or because all the elements in both the arrays are unique. Now when I do set 1 minus set 2, what I get? 1 will be there, 2 will get subtracted because it's present in both. Oh, sorry, I don't have to write it. Then 3 is not present here, so 3 will come. Great. Now when I do S2 minus S1, what we get? We get 2 in both common, right? We get 4 because it's not present in S1. We get 6 because it is also not present in S1. So finally, we return 1, comma 3 and 4, comma 6. This is our output. Fine. I hope you understood this simple dry run. Now let's take another example. In this case, we have 1, comma 2, comma 3, 3, and 5. Great. We convert it to a set. Right? What we get? We get 1, 2, 3, and 5. Fine. Now for second, we get 2, comma 3, comma 4, comma 4, comma 6, and we convert it to a set. And it is of 2, 3, 4, and 6 because all unique elements will be there. Now we subtract S1 with S2. We get what? 1 is present in S1. It is not present in S2. So 1 will be here. 2 is present here, 2 is also present here, so we cannot take this. 3 is also present here, here also it is present. 5 is not present here, so we can take 5. S2 minus S1. 2 is present in both, 3 is present in both, 4 is not present in S1, right? We take 4. And I guess 6 is also not present in S1, so we take 6 also. And at the end, we return 1, comma 5, comma 4, comma 6. Fine. That's the thing. Always keep in mind when you do S1 minus S2, it will if from S1, all the elements which are common or basically which are in S2 also will be eliminated, and all the elements which are not in S2 will be present. Similarly for S2 minus S1. Okay, I hope you understood the dry run. And if you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition. And also, if you don't know about set data structure, just go through that also and the approach, and after that the code. Now, since you're familiar with the problem and solution, let's move to the lead code and code the solution. So what we did first, we created a set one, set, putting nums one here, then set two, putting set, converting into a set, then result one, having converting into a list, converting the set into a list, and doing what? Set one minus set two. Result two, also the same, set two minus set one, and we return result one, comma result two. Submit the solution. It got accepted. Now also I have a final submission. Okay, it got submitted. Great. Now code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.